Good evening. Today we are going to see the connection systems. And in this, we will first go, that is single lacing system. So we have this as lecture number 16, that is revision lecture. And we are going to solve the problem. Design a single lacing as connection system for a built-up column with two ISMC 300 at 358 Newton per meter connected back to back. Spacing between channels is given 200 mm and gauge distance is given 50 millimeters. And slenderness ratio is 90. So now first we will go with given data. So we have step 1. Step 1, given data. And we will show this data in diagram. So we have, this will be two channels. We have given this distance 200. Then we have given gauge distance, means where we have bolt. So this is given as 50. This also we have given as 50. And then lambda, that is slenderness ratio, L by R minimum. This is given as 90. These are two ISMC 300. So we have these two channels, ISMC 300 at 358 Newton per meter. And we are interested, this is step 1 given data. Step 2, now we have directly, that is single lacing. Now we will start with this single lacing. Now you can go to clause number 7.6.5.1. So now I will actually draw this lacing diagram. So I will go to the next slide, and there I will draw this diagram. So we have, so channel, now we have back to back, so we have thickness over here. So this is one channel. Then we have another channel. So this is again thickness of web. And then we have this as other line. So we have these two channels, and this distance we have given 200 mm. Now we will show the lacing. So I will just change the color so you will understand it on better side then. So now we have single system in this way. So we have, this will be flat. Then we have on this side another flat. We have bolting over here. We have bolting over here. Bolting are not overlapped. Then we have gone over here. Then on this side we have. So likewise we have these flats. Now what is A1? So we have A1 spacing of lacing, and this is my spacing of lacing. So this is distance A1. Now this is 200. Then we have this distance, that is from bolt. So this is given as 50. So we have given this distance. This also we have 50. So total we have distance between the bolts. This goes to 300. All dimensions are in millimeter. Then from this, we are going to get this spacing of lacing. Again, I will take another color. So we have spacing of lacing. And now we will assume this angle that is 45 degrees. So we have this as isosceles triangle, and this 45 degrees we are going to consider that is given in IS 800. And if I will go to IS 800 7.6.4, so theta that is given 40 degree to 70 degree, preferably 45 degree, and clause number we have 7.6.4. And therefore what will happen, we have this distance that is 300. So 45 degrees, so automatically we have this also 300, and we have this also 300. So total A1 we will get it as 600 millimeters. Now we have, this is our length of spacing, lacing. So this is L, length of lacing. How we will get this length of lacing? So we have this as 300 and angle is 45 degree. So this also we have 45 degrees. So we have L upon 300, and that is equal to sine 45. And from this we will get L equal to 300 upon sine 45. And from this we will get length of spacing that is equal to 424.26 millimeters. And now we will go one by one step. So if we will go to clause number 7.6.5.1, we have first criteria A1 upon R minimum, and that is of individual element. Individual element means we have this value of R minimum. This is of RYY, that is of ISMC 300. And then we will put A1, we have calculated 600, and R minimum, that is RYY for ISMC 300 is 26.7. And we will get this value 22.47. This value is less than 50, and this value is also less than 0.7 into 90, which is 63. This is according to clause number 7.6.5.1, page number 50. Then we have next, that is transverse shear VT, and that is 2.5 upon 100, 2.5% of axial force. And axial force we have 1100. Actually in problem it has to mention, so I will mention here axial load is 1100. That is also given over here 1100 kilonewton. And then we will get from this 2.5 upon 100 into 1100, and we will get this value 27.5 kilonewton. We have this clause number 7.6.6, page number 50. Now knowing this, we are going to find out force in each channel. So it is assumed this is in two channel, or we are going to say it is in one plane. Other plane we have opposite side, so books are given different. So here we will say force in one channel. Force in one channel, and that is equal to V by N, and that is 27.5 divided by 2, and we will get this value as 13.75 kilonewton. Now this force we have along this transverse shear, and we are interested to find force along the lacing. And then for this we will get, therefore, force in lacing that is equal to, now you can take cos 45 and from this you will get this as V by N cosec of 45, or you can have sec of 45, one and the same thing. So 45 we have assumed here, so we have on both sides 45. So V by N we have 13.75 cosec 45, and we have this value as 19.45 kilonewton. Now we have to go for lacing flat. Now for this lacing system, we are going to use lacing flat. Now we have width of lacing. Width of lacing. And that is equal to 3 into diameter of bolt. Now we will assume 16 mm diameter bolt. And then from this we will get 3 into 16, that is 48 millimeters. Then we have thickness, this clause number you can see, we have 7.6.2. Page number we have same 7.6.2. Then we have thickness of lacing. Thickness of lacing 1 by 40 into length of lacing. Length of lacing. So we have 1 by 40 into 424.26, and we will get this value that is equal to 10.60 millimeters. So this is according to clause number 7.6.3. Therefore, provide size of flat. Provide size of flat 50 by 12 millimeter. 50 millimeter by 12 millimeter. Now we have to find out strength of this. So we have given this as 50, we have given this as 12. And then we have to find out strength of this. So we have R minimum that is equal to I by Y, and that is BT cube by 12 divided by T by 2. Because moment of inertia about this we have BT cube, and from this we will get it as I by Y, that is root of I by Y, and from this we will get R minimum that is equal to T by root 12. So this is not T by 2, we have this as B into T. So BB cancel, T becomes T square, and 12 will be there. And from this we will get value of R minimum that is equal to, we have taken thickness of flat as 12 millimeters. So we have 12 by root 2. And from this we will get value that is equal to 3.46 millimeters. Now we will find L by R minimum. Now L we have already calculated 424.26, which is length of lacing. 424.26 divided by 3.46, and we will get this value 122.62. Now as we have flat over here, so I have buckling class as class C. Buckling class C, because we have rolled section we can say, or flat we have, so we have class C. So use table 9C. Use table 9C. And now we have over here KL upon R 120 and 130, and we have value of FCD 83.7 and 74.3. And from this we will get value of FCD, that is equal to 83.7 minus 83.7 minus 74.3 divided by 10 into, we have 120 we have taken reference, so 122.62 minus 120, and we will get this value as 81.24 Newton per mm square. So 81.24 Newton per mm square. Then we have to find PD, which is equal to AE into FCD. AE we have 50 into 12 and FCD we have 81.24. And from this we will get 50 into 12 into 81.24. That is 48.74 into 10 raised to 3 newtons, which is 48.74 kilonewton, and this value is greater than 19.45, which we have calculated force in lacing. Then we have to check its tensile strength also, and we have tensile strength, it is minimum of first TDG, which is AGFY upon gamma MO. Now we know already clause of this, that is 6.2 page 30, and we will get this value 50 into 12 into 250 upon 1.1, and we have this value 136.36 kilonewton. And if we will go second TDN, and that TDN is 0.9 into ANC, and ANC we will take it as B minus ND into T FU upon gamma ML. And from this we will get 0.9, B we have 50 minus we have 1 volt of 16, so 18 into thickness 12 FU 410 upon we have 1.25 and we have 113.36. And we have this value. Therefore, TD we have 113.36. Again, it is greater than 19.45 kilonewtons. And therefore, safe. Now we have connection. And now in this connection, we have VDSB. Now I will just write the formula. FUB upon gamma MB, root 3 gamma MB. And we have single shear, and therefore NS into ASB. Now you can write values, and from this we will get 1 into pi by 4 into 16 square, and we have this value that is equal to 38.09 kilonewton. And second we have VDPB 2.5 kb dt fu upon gamma ml. Now kb we cannot find, we do not have spacing and all this, so we will directly assume value as 1, d we have 16, t we have 12, fu we have 410, and gamma ml is 1.25, and we will get it as 157.4. And then we will consider, that is VDB as 13.09 kilonewton, and number of bolts equal to force we have 19.45, and divided by we have this value of force, that is bolt value is 38.09. So this is less than 1, therefore provide 1 bolt. So likewise, we have to go for the connection. We have to solve the problem of single lacing. And now we will stop here only. So thank you.